During 1957, giant trailers bearing large, cloaked, cylindrical objects have left California and moved across the country to the East Coast. Under the nylon security cover, being transported from factory to test area, is Atlas, one of our intercontinental ballistic missiles. The people of America have been little aware of the significance of these movements. For most, as the trailers rolled over the bridges, past the farmlands and through the cities, for most people watching, this was just another tank or boiler or oil rig. Too many strange objects have passed over the highways of this country for people to wonder anymore. But during 1957, events occurred in other parts of the world that focused attention on these covered missiles. Russia announced in rapid order the test of the ICBM, the satellite Sputnik 1, then Sputnik 2. So when it comes to a flight test of an ICBM, such a test is the end result of tens of thousands of prior tests of components, assemblies, and subsystems. This, then, is Atlas today, a thing compounded out of the new gadgetry of the ballistic missile age, a giant whose vital organs have been given a thorough physical, a robot capable of obeying instructions in an almost human manner. Yet for all of this, still a machine. A machine still not ready for Air Force use until every one of its mechanical quirks and patterns of behavior are well understood and proven reliable. A horse can be judged sound as a dollar, but there is still the question of whether he can do the mile and a quarter. The judges in America's race to perfect an ICBM hold forth in a mass of concrete called the blockhouse, only a few hundred yards from the launch pad. This is like a consultation room for men of medicine. Here, each man is a specialist in his own right. Here, diagnosticians still feel the pulse of the patient. This man and his instrument panel watches the fuel system. This man monitors pressurization. This man can tell if telemetry checks out. Here, TV cameras relentlessly study the bird to visually find flaws. Other men at periscopes scan the launch area as another check against failure. At a central panel, the test conductor receives reports from the monitoring stations, estimates the overall situation, and controls the firing button. The countdown for today's Atlas shoot is in progress.
Minus 130.
Fittingly, it was a gamble with nuclear energy that was one of the key factors in finally triggering off the present stepped-up ICBM program. When we achieved a breakthrough in thermonuclear or hydrogen weapons in 53-54, thinking changed overnight. Now it was possible to have a warhead of a size and weight in keeping with the overall ballistic missile concept.
We had our powerful warhead. However, to go ahead with the ICBM idea, another problem had to be solved. The missile's nose cone, which contains this tremendous explosive force, had to re-enter the atmosphere without destroying itself before reaching the target area. To understand this problem, it is necessary to review the steps involved in an ICBM operation. The missile first moves straight up under the combined thrust of all engines. At a certain distance above the Earth, it is programmed into a tilt, which aims it into a curve or arc, calculated to intersect the Earth some 5,500 miles away. After providing the initial push, the booster section disengages and falls back to Earth. The missile continues on its sustaining engine until maximum speed is attained. At this point, the nose cone containing the warhead separates and continues on its established arc to the target. During most of its flight, the nose cone is traveling above the atmosphere, but as it reaches the target area, it once again enters the air ocean. The friction of the re-entry body pushing through the thicker air at high speeds could cause the nose cone to glow red hot and then disintegrate in much the same manner as do meteors entering the outer atmosphere.